Welcome to Through the Noise. I'm your host, Ernesto Glucksman. Those wind turbine blades, those giant ones that they have to bring on a truck and weave them through a town road to get them into place. Well, after 20 years, 25 years, something has to happen to them. And so far, they usually go to a landfill. My next guest has a way to deal with those that is interesting, to say the least. Chris, thank you for jumping on with me on the show. I really appreciate you setting aside your time. You got a busy initiative that you've been probably working on for the past year. Let me read some of your street cred. You're the senior director in recycling operations for Veolia. Did I say that right? Veolia. I should have softened the A at the end. Veolia, French company, but subsidiaries and partnerships all over the world, right? Big company in waste management, energy systems, recycling. I think the really interesting aspect of your career is you started in nuclear with the Navy, right? And
yes, yeah. By training, nuclear, but by trade, it's been predominantly in the water treatment business, and then only recently working on the waste and recycling side.
So you were in mining operations too. I mean, you've been at Veolia for what, 20 plus years, something like that?
28 years coming up. So
okay, so we got the company guy that's seen probably all kinds of changes and adaptations to the business. The really intriguing aspect is you've landed yourself in this group that is looking at wind turbine blades and what to do with them once they reach their end of life, which is around what, 20, 30 years they have.
Correct.
So can you give me a little, like when someone sits down for that dinner table conversation, you don't know anything, and they ask you, it's here in Washington, it's just what do you do for a living? What do you tell them?
Yeah, they kind of freak out a little bit when I talk about recycling and repurposing wind turbine blades. But it was quite a journey to get here. As you mentioned, I've been with Veolia a long time. I had a global role where I managed mining, metals, and the power industry for Veolia, and was a subject matter expert in those three industrial groups. And as a result, Veolia has sent me to over 40 countries throughout the world to help establish our offerings in various countries related to those market initiatives. And it's been a fascinating journey. It really has. Seen and met some folks globally that are just incredible. Everyone asks, are the people nice there? People are nice everywhere. There are bad characters no matter where you go, but I've never been anywhere where I didn't really enjoy being there. And so Veolia afforded me that opportunity to travel the world and help establish business in various countries and be a resource. And as part of the power initiative in Europe, predominantly or initially, the question was what to do at end of life for renewable energy components and predominantly wind turbine blades. And so we started the journey actually in Europe. Europe's much more mature from a renewable energy standpoint than we are in the US. And so they were actually reaching end of life for their generation of renewable energy. And Veolia was approached and asked, hey, we can recycle all of the materials in a wind turbine, but we're having some trouble with the wind turbine blades. Can you help us out? And as you mentioned, Veolia's got it's the world's largest environmental services company. We've got significant waste opportunities and waste solutions, both hazardous and non-hazardous, throughout the globe. And we were able to look at our network of information that we had to try and find a solution for wind turbine blades. They're big, they're bulky, and up until this point, there's really not been a viable recycling or repurposing technology for wind turbine blades. So we went down a couple different roads looking at how to do that. And there's a lot of interesting ways to repurpose or to reuse or recycle wind turbine blades. Currently, there's no aluminum can becomes an aluminum can type of recycling capability for wind turbine blades. It's more of a repurposing. So we call it repurposing just not to confuse it with recycling. Because the general public looks at recycling as I throw something in the recycling bin and it probably comes back to me again when I buy a soda or some other beverage in that type of container, whether it's glass or whether it's aluminum or whatever it might be. And that's not where we are with the wind turbine blades. So the other real strategy and challenge was to be able to do things at scale. There's some really cool things people have done with wind turbine blades. They're making pedestrian bridges out of some of them. They're looking at sound barriers, bicycle covers, parking covers, just some really playgrounds for kids. Those are going to be able to address maybe 100 blades or a couple hundred blades. And we need to have a strategy that represents thousands and thousands of blades. Because wind energy, as you know, and renewable energy in general, has really taken off. The largest markets for wind is in the US and China, and they're the largest growth markets as well. And there's a combination of what we call onshore and offshore. Onshore is huge in the US and in North America. The offshore is just starting to take root. So we developed a strategy starting in Europe and then brought it to the US to repurpose wind turbine blades. So yeah, that's what I do for a living.
What, can you give us a little bit of what's the primary material of these wind turbine? Fiberglass, probably, right?
Predominantly fiberglass, also balsa wood. There's some foam material. Think PVC foam that you might see, spray insulation type of foam material. And there's a little bit of metal in them as well, primarily for lightning protection.
And so these are like materials that are sort of bonded. They're pulled for strength, but some flex. Has to be super light, right? That's the idea. And they're huge. Like you have to move these through a road. You have to kind of block off roads and all of that, right?
There are people's career, all they do is figure out how to get these large components from point A to point B. And it's a significant undertaking. But you're right, they're very large. They're anywhere from 150 to 300 feet long. Think of them like an airplane wing. And they're look very similar to that. They're light, but only in a relative standpoint. Yes, they're light, but these wind turbine blades weigh anywhere between 6 and 10 tons.
Just the size of them.
Each,
right?
Yeah, they're huge. And as you mentioned, they're predominantly fiberglass. They're very strong. They're very durable. They are designed to last 20 to 30 years, as you mentioned. And they're very robust. The engineers that have designed these blades, kudos to them. They've made an incredibly robust piece of equipment, which makes it incredibly challenging to destruct the material for us to be able to repurpose it.
And so the repurposing is you're trying to avoid having to take these things down and then take them into landfills, right? Because there's some benefits in these materials to, if we can find some secondary purpose for them, you then have some of the additional benefits, I guess, not having to create the raw materials for whatever it is, the other product you're repurposing them for. But what does that look like? Can you give us just a sense of like how are you breaking these materials down and where are they then going to? What's the market then you can then sell those as input materials?
Sure. So again, globally, different regions have different needs. And so, for instance, in Europe, it is illegal to landfill wind turbine blades in Germany.
Oh, okay. That's a big problem right there, right?
Well, yeah, and that's part of their regulation. We don't have any of those regulations in the United States. It's perfectly legal to put this material into a landfill. It's a very benign waste. It's certainly not hazardous. The problem is it takes up a lot of space and it's going to be there in the perpetuity. It doesn't break down over a period of time. And certainly the optic related to green renewable energy and then at end of life that material going to a landfill certainly isn't what the industry would like to see, nor would we like to see that. So yes, the ultimate goal is to keep this material out of the landfill as much as possible and find an upcycle, if you will, from a landfill opportunity up to repurposing the material to be useful in something else. There will come a day, and the industry is working towards a truly recyclable blade. But in the interim, we've got the already established base of wind turbine blades that are already there that are going to need to be managed. And up until the time in the near future when they do come up with a fully recyclable blade, we'll still have to manage the blades that have been installed throughout the U.S. and throughout the world. So that's what we're looking to do. The industry, the renewable energy industry, is certainly very aware of the need to look at alternative manufacturing strategies that encompass circular economy into them. So more recyclable material. We've got to become more circular in what we do. We all live on this one spaceship, and we have a finite amount of resources, and we've got to be able to source what we can from things that we've already made, and that's what we're doing with the wind turbine blades.
Sure, but there's depending on the regulatory environment in Germany, they probably have a very compelling market force to repurpose the blades, right? In the U.S., maybe not so much, right? So then a secondary market where you repurpose this might have a different value for the materials, right? Because you have to balance those situations out. So where are they going in the U.S.? Like, where's your target? Like, where could this be then used as you shred this thing up?
So I'll tell you what we're doing right now, and then I'll tell you other potential opportunities. Okay. Right now, we take the wind turbine blade and we go through a number of sizing operations. In essence, we are shredding the material to come up with a finished product that is less than 2-inch minus. So you can imagine a 160-foot, 7-ton blade ultimately gets shredded into material that's about the size of a quarter or a $50. And that material currently is being used for cement co-processing in the U.S.
Okay.
So then you're going to ask me, what is cement co-processing?
Well, a little bit. I did have another guy on the show prior episode gave us a new method with cement, cement engineer. But cement basically has there's the raw materials that go into making cement creates a lot of gases, offset gases. So you're supplying this material into that process to
you're right.
reduce, right? What are you getting at? What is the customer getting if they can get your stuff?
Sure. So the cement industry is the second largest emitter of CO2 next to oil and gas. And you can imagine as we continue to grow as a globe and certainly as a nation, and certainly a lot of discussion about improving infrastructure and such, we're going to have a continuous need and an expanded need for more cement in order to address what we need to here. So the cement manufacturers are very interested in what they can do to reduce their CO2 footprint. So this material, when it's used for cement co-processing, it does a number of things. A little over 90% of the entire blade can be repurposed. And in the cement industry, they use coal, typically, in order to provide the energy necessary, the heat energy necessary to make cement. And just so that you know, cement's the powdery stuff you get in a bag at Home Depot or Lowe's, whereas concrete is the material that you ultimately pour and make roads and sidewalks and such. So the actual manufacture of the cement is a pretty energy intensive operation. It's also chemically intensive. There's a recipe necessary to make the cement. So this material can be used to displace the use of coal as an energy source in cement manufacturing or cement processing, hence the name cement co-processing. So the cement industry is getting the benefit of using this material and being able to displace coal. About 28% of the blade weight replaces the energy needed for cement production. And so right there, you've got a CO2 improvement of this material versus the coal. 27 to 28% of the material in a wind turbine blade is considered biogenic, which means it's non-greenhouse gas forming. So that's where you get the CO2 emission benefit.
Okay.
Unfortunately, if everyone has ever seen a Corvette burn, a Corvette's predominantly fiberglass, there's a lot of heat energy there. It's not like metal. Fiberglass has resins in it, and those resins
you can burn the heat or apply to a process.
Yep. And so if you think of the residual, or what some people might call ash, the residuals then are raw components such as silica, calcium oxide, some aluminum and iron, and all of those things are necessary to make cement. So the residual from the combustion that occurs in the cement processing now displaces raw materials that would otherwise be needed for the cement manufacturing. So, when you look at about a 7-ton blade, where the cement industry is avoiding about 5 tons of coal.
It's like 14 Corvettes, right? Maybe, or maybe a little more, 20 Corvettes.
And unfortunately, they're crushing a bunch of them on Bowling Green due to the recent tornado. So that hurts. I'm a Corvette guy.
Okay.
You've got about 2.7 tons of silica and 1.9 tons of limestone for every one of these 7-ton blades that is used in cement co-processing. So it's a win-win-win for everyone there. It's again, it's not a wind turbine blade becoming a wind turbine blade again, but it's significantly better than it being in a landfill. It's much better than incineration, because you could incinerate this material and go from waste to energy. When you do that, you do still end up with an ash that needs to be landfilled. So here the ash component, if you will, reports to the cement and becomes part of the cement. So it's a total 100% repurposing and upcycling from a landfill application for the wind turbine blade.
So you could burn it to get energy extraction out of that, and then reuse the ash put that into the cement as well, right? Is that?
No, you wouldn't typically, if you're going waste to energy, which there are a number of facilities in the U.S. that do that. A lot of municipal waste to energy facilities, which is a great application for municipal waste. It would be very challenging because you're commingling so many different materials.
Okay.
Ash then becomes a conglomerate of a number of different
different materials that didn't burn efficiently that are in there, and you can't then. Okay.
Exactly, and it doesn't seem as though it would be economical to have an incineration process for just wind turbine blades.
So maybe in Germany they could do that because you can't landfill these giant blades, but
Germany,
the ash.
They do the cement co-processing, Ernesto. That's what they do.
Gotcha. So this is really interesting. So I mean, it's like the design of this process, and you guys already have a customer. I think you're working with GE, right, as part of the development of this program. But I guess how do you scale? I mean, there's one aspect of the scale. These things are so big, right? They're 7 tons all in one go, and I guess you could on site take the blade down and then chop it up. You don't have to block off a bunch of roads, right? You could probably cut the blade up quickly and move it to
that's exactly what we do, Ernesto.
Okay.
We would take this 150, 170 foot long blade, and when it's removed from the wind turbine with a crane, once it's set on the ground, then the blade would get cut into 40 to 50 foot sections and loaded on a very traditional flatbed truck for transportation, so that you don't run into the transportation challenges that you have with a brand new, fully intact blade. We also don't have to treat it with kid gloves like you would a new blade. So that's exactly what we do. We start reducing it in size in the field, and then continue to reduce it in size through a number of different processes.
So where did you get brought into? I mean, because I'm sure that this type of, in such a large group, there's other colleagues, other, leadership that, probably were tuned into the potential opportunity for Veolia. Where did you get brought into this program when, because you have more of a business background, right?
Correct. So more of a business development thing. And
Okay.
in that global power role that I was in, we were approached in Europe to find to help develop some strategies. The first approach for us in a relative similar application was for carbon fiber, and Airbus came to us and said, look, we're manufacturing our airplanes predominantly more and more out of carbon fiber.
Those
Is there a
wings.
way? Yeah, well, is there a way to recover the carbon fiber waste just from the manufacturing? And we went down that road, and that was going down that road was really the opportunity for me to say, hey, is there something we could do with fiberglass as well? Because they're very similar in the way that they're manufactured. And the answer was yes. So we looked in Europe at first at different strategies in order to recycle the material in Europe. And what we were finding in Europe was every country in Europe has its own regulation. Germany is the only one right now in Europe, for instance, that prevents landfilling. The EU typically operates as one unit, but in this particular case, as it relates to waste, each one of the countries has its own regulation. And you couldn't take a blade, for instance, that was taken from a windmill in France and ship it across the border into Germany or into Spain to do something, because they categorize those materials in different ways. And because they did that, we couldn't establish the necessary scale or the number of blades that we would need in order to have a business case to make an investment in Europe. And that's when GE Renewables approached us and said, hey, we've got this thing called Repower in the United States, which is resulting in a very large number of blades. Would that volume potentially be enough for you to establish a business case in North America? And the answer was, well, maybe. And that started the dialogue. And you're right, that was more of a business development role on my behalf, working with a counterpart in GE Renewables, Michelle Simpson. And Michelle and I just started having some great conversations, very transparent. We already do work for GE in a number of different applications, so we know each other. And fortunately or unfortunately, big company talking to big company is a different dialogue sometimes in big companies and little companies and vice versa. So we understood what our respective challenges were from the big company standpoint. And it really blossomed into the partnership that it is today. We've got a long-term partnership with GE Renewables to manage their blades in the United States. They have other relationships with other providers. They've got one, for instance, in Germany, and it's not with Veolia, it's with someone else. And we're perfectly okay with that. And we discuss those things, and it's a great partnership. So the scale that GE was able to bring was enough scale for us to establish a business case and subsequently take to our leadership in North America. This is our strategy. This is the investment that we need. This is the rate of return that we expect, et cetera. Can we move forward with this investment? And the answer was yes.
Just sorry to interrupt there, but that's particularly interesting because story on, in Europe you just presume, oh, they have a more aggressive stance on renewables and process, dealing with responding to climate change. But then you realize the cross-border issues of getting materials into one area or the other then becomes the thing that blocks, and to get to a certain scale. But then the opportunity in the US, even though we're not quite there yet with applying more pressure into industry to get things going, the scale is available for you guys to then and the scale means put the money for a processing plant and deal with contracting enough employees to then be able to collect these turbines, develop a sales approach to start reaching out. Well, I guess you don't have to reach out to anybody. You're working with GE, so they can tell you when they're decommissioning one of their turbines, right?
Yeah, certainly GE is doing what I mentioned, repower. We can talk about that in a little bit, which generates a considerable number of blades. I would expect the EU, and the EU continues to move forward with a cohesive strategy that embraces the EU as a whole. They've got some great initiatives in Europe. Europe tends to drive things by regulation. Free enterprise tends to drive things in the United States. And so, although there's no regulation specifically that requires the repurposing of wind turbine blades, the industry understands now that there's a solution that it's good business. Mm. And so there isn't necessarily the need for regulation to drive the business of wind turbine blade repurposing. And that's a good thing, because that then allows capitalism to be in place, and it drives Veolia to be innovative. It drives GE Renewables and others to do the right thing for a circular economy solution. And we're going to have competitors in this market. We are the first to market with a process that allows enough scale to address the need in the United States. We've processed well over 1,000 blades in the last year.
So 7,000 tons. And the scale component is the thing that's a challenge, because when you go to the cement manufacturers, they're like, great, this is great stuff. How much can you make, or how much can you consistently deliver to us, so then we can start implementing into the process? You're probably not going to be able to get all the material. It wouldn't offset everything, the raw inputs that they have to pull in to create at the scale that they're at, but it begins the process where you're sort of supplementing some aspects of it, right? And they're going to ask you, how much can you grow? How quickly can you process? How much you can deliver, and I guess volumes, right? And that's the other half of this. It's not just like in understanding the problem, creating a process to transform the raw materials. I guess you call it repurpose the, what is it, REM or something?
Yeah, REM, yeah.
You have to be able to then deliver to the customer in a consistent enough basis that they can count on, right?
So Veolia had a significant advantage. And you're right, Ernesto, there's lots of chicken and egg through this whole process. A lot of things in parallel, moving. One of the advantages that Veolia has is that we did not have to establish the relationship with the cement kilns just for wind turbine blades, because we already had relationships with cement kilns. Cement kilns, not all of them, but a large number of them, used engineered fuels for their process. And this has been going on for decades. So a lot of waste management being done at cement kilns. And because Veolia is the large waste management company and environmental services company that it is, we already had those relationships established. So if we had to establish those from the very get-go, that would have been another chicken and egg that would have been very, very challenging to connect all the dots and make sure that you had enough volume on the intake side, you had enough money on the investment side, and then you had the offtake capability. Veolia kind of already had the offtake capability. We understood how that works. And so that's actually prevented some folks from getting into this. There's been some false starts in the United States with people securing the intake portion. They've got some great ideas of what to do on the process side, but they couldn't manage the offtake portion. There are folks that would say, yeah, we'll take all the material that you can give us. How much can you give us? And just call us when you get your processing facility built. Well, they couldn't get the money for the processing facility to be built unless they had an offtake agreement.
Right. Purchase order.
Yeah, exactly. And
MOU.
it wasn't for, a few tons. They wanted thousands of tons of material. So that was a real challenge for the industry. Again, we've had to overcome some of the negative momentum associated with some false starts in the industry. But what we're doing right now is meets that scale. And you're right. If we had just one cement plant, could take all of the material that we make an entire year. So,
what was sort of the watershed moment for you throughout this process where you're like, oh, okay, this is actually going to work?
We couldn't have done it without GE Renewables being there as a partner. And so it was them being able to dedicate the volumes necessary to make it work. And part of the watershed moment was we already had a facility in Louisiana, Missouri, that was engaged with engineered fuels going to cement kilns coming from medical waste. And so, they put up their hand through this process and said, hey, I think we can help with this wind turbine opportunity. So it wasn't me driving this from beginning to end, quite the opposite. A very large group of people, very collaborative communities within Veolia, and being able to connect the dots, so to speak, and being able to discuss things with various subject matter experts. Well, we can send this material to kilns, but is there going to be a detriment to the kiln? What about air emissions? All of those types of things. Permitting. There's a number of different cogs in the wheel to make things work, and it isn't Chris figuring out all of those. It's a lot of help from a lot of different people, and definitely a team experience and effort, and it continues to be. And I suspect what we're doing today, we won't be doing 3 years from now. We'll be doing something different. We'll have to innovate and continue to find other opportunities, and we're already going down those paths. We want to diversify away from just cement co-processing and look at other opportunities, and other opportunities are presenting themselves. And they're not necessarily just developed by Veolia. They're in partnership and collaboration with other really smart folks out there.
Well, how do you then, it's interesting, how do you spend your time then? How do you, you're on the business side, so you're sort of need to keep networking and keep talking to a variety of folks from different teams within the company, but also your partners and relationships you have outside. How do you go through prioritizing in your day? Oh, that's, hey, what about those Corvettes? They make tons of Corvettes. Can't we grind those things up, right?
Well, it's a business. And so, certainly the leadership that I respond to is it's got to be a viable business. It's got to be profitable. So, that's my number one priority every single day is to make sure that this has been a startup. Veolia is certainly not a startup company, but this is a startup enterprise within Veolia.
Business unit startup, right?
The business unit startup. And so we're a year into this, a little over a year into this. So it's very much been a startup. We've had our hiccups and hurdles like any startup would have. So my priority on a daily basis is making sure that what we said we could do to management, that we do, and then also making sure that we continue to stay client focused and that we provide the solutions that we've committed to for GE Renewables and others. We're not exclusive to just GE Renewables. We certainly value the partnership that we have with them. But I think by design, GE didn't want to be exclusive so that we could provide an opportunity to the entire market, because GE Renewables isn't the only one providing wind solutions out there. And if someone else has a black eye, perhaps that's a black eye that could spread to GE Renewables and vice versa. So kind of a open source type of strategy from GE, which I think was incredible. A great deal of intellect went into making that decision. And
it just sounds that there's a lot of people, they know that there's the potential is so significant if they can get enough people doing it in different aspects, that why make it exclusive to one line of processing, right? Like there's so much more that we can do. The hard part is like, can we do this? Can this become a viable relationship across all these companies, right? Am I characterizing that right?
yes, we certainly have a contract with GE Renewables, but we're talking and working with and accepting blades from others, and we'll continue to do that. What the wind turbine composite repurposing has allowed us to do is then to look at other materials that are much smaller in volume that would have not made a business case by themselves. So folks are manufacturing utility poles out of fiberglass instead of wood in order to improve the longevity of utility poles. They also would like to have a greener solution on what to do with their waste. So
At the end of life.
at the end of life, boats, pleasure boating.
Oh yeah, that's all fiberglass.
It's all fiberglass. Unfortunately, hurricanes are horrible things. You see a hurricane, what's the image you always see? You always see these boats, stranded and damaged. And, where do those boats go? Well, probably a lot of them, after they've been stripped, they end up in landfills. So we're evaluating that. The real challenge is transportation logistics. All of this stuff is large.
Getting it from there, processing it down. Can we do it on this site versus another site? Right.
Exactly.
And then probably finding the number, like if there's a boat graveyard, that's probably a good place to then maybe.
Mm-hmm. Well, it could be. And you know what? We don't do this as a charity. So,
right.
There's got to be a motivation on the material in the beginning. And then obviously I have to have an offtake capability as well. So there are things that the cement co-processing folks don't like to be in the material. So we don't just shred the material. We also go through a significant sorting process. We sort the things that they don't want out. And we also blend some other things in. So some of the facilities will take some of the medical waste composites that we also manage, and we'll make recipes, if you will, of this repurposed engineered materials that we send out to the cement kilns.
What, given your extensive experience at the company you've been with, I mean, you've probably seen all kinds of initiatives and projects come and go as just, as part of the testing, if there's even a market for something. In this particular project, what's been the most surprising thing you've learned from, at least within the past year since you've been heavily involved?
Sure. I guess what I've realized being exposed to it is there's a lot of blades out there, and not just from GE, from a number of others. And there are a lot of folks that are looking for solutions for them. On one hand. On the other hand, there's a lot of composites out there where people are looking for opportunities to be more environmentally responsible on what they do with them at end of life. This one will sound strange. Where do you think mannequins go at the end of their life? It's kind of been a pet project. I've been working with some folks.
Oh, really?
And, yeah, they're legitimately looking for an environmentally sustainable solution of what to do with mannequins, which are made predominantly of fiberglass and other composites. When you look at a pie of composites and you look around your office, your home, your business, composites are everywhere. The wind turbine blade slice of the pie of composites is maybe only 7 or 8, 9% of a slice of a pie. You've got all that other rest of the pie that perhaps we can do something with. I'm not saying that Veolia is going to do that. I'm just saying that there's quite a bit of opportunity for us to expand the management of composites through what we have started with, first with low volumes of medical waste and now much significantly larger volumes of wind turbine blade material. So, that's another watershed moment. Is it's not going to be just about wind turbine blades. It's going to be about other stuff as well. But certainly wind turbine blades right now are our focus.
Do you go through your day and sometimes you're like, wow, there's all this like embedded value that if we just could get, the sorting right, if we could just get the extraction right, we could pull out a lot of cash out of the process from a variety of materials. I mean, just probably driving down the road, not just seeing those Corvettes, but everybody else's. Is that how you think now? Is that part of your?
Well, I certainly have a much broader horizon to look at, and be honest with you, it's kind of easy at the moment. I've always been in a business development mode where I'm knocking on doors. It's quite the opposite. It's a lot of people calling us and asking for
Oh,
solutions.
what's
And
that like?
well, I mean, it's refreshing. It's also incredibly um, refreshing to know that people are looking for environmentally sustainable solutions for something. Believe me, it's cheaper to put it in a landfill. It's cheaper to put those mannequins in a landfill. It's cheaper to put that other fiberglass waste materials in a landfill, and they're allowed to. There's nothing that prevents it from happening, and yet they're looking for environmentally sustainable solutions. And
That's the unusual part. What's your opinion on the future, 10, 20 years from now? Is it going to still be cheaper to do that? Or do you think it's cheaper until it's not, until something pushes
yeah,
you?
Ernesto, it's cheaper until it's not. There are landfills now that will not accept wind turbine blades, primarily because they don't think they're going to get bigger landfills permitted. And this material takes up a lot of room. So they're going to look at higher value materials from a business standpoint to go into the landfills. And it's increasingly more challenging to get landfills and just waste management facilities in general permitted in the United States and globally.
So that adds a little bit of that compelling, like we should start investing or looking at other opportunities. And then the customers are also bringing that energy towards you're a wind manufacturer. You don't want the PR of like, well, what happens to all of the stuff you've made? Like how really environmentally sustainable is this business line of business you're in, right? That's just part of that aspect. You're sort of conversion. Are they going to come together at a certain point where you guys are in a good spot to make a lot of money?
Well, and I would say I'd love to say this is a hugely profitable business, and the bank cars are just rolling out of here with buckets of cash. That's not the stand. That's not where we are, and I doubt that that's where we will be. We certainly need to be profitable from a business standpoint, but Veolia isn't in it, for the cash, so to speak. We certainly have to be profitable from a business standpoint. Veolia is very engaged with circular economy. Our buzzword is ecological transformation. We're in the midst of an acquisition of Suez, and one of the main reasons for that acquisition is to have enough additional scale to really provide ecological transformations that benefit the planet in a substantive way. Uh, don't mean that to sound, all very cliche and so forth, but we are a French-based company. Europe has traditionally been more environmentally focused, perhaps than other regions on the globe. And because of that, that's one of our mission statements, is to drive ecological transformation in this wind turbine blade and renewable energy resources in general. Finding circular economy applications for them is what we wake up and do every single day. We also have a phrase: we are resourcers. We're looking for opportunities to resource materials and just be better stewards of the planet. And
Well,
we've got to do that in a business that can still be substantive and sustainable from a business case standpoint also.
Right. And that, do you include in your projections the transportation costs? Of course, everything gets costed up. Like, right, you have to, well, where are these turbine blades being decommissioned, and how close is it to our facility that can do something, and how close can we get to, the customers that we want to provide this material for? Like, all of that has to be put into these plans when you go then to your leadership and you're like, okay, we have something we can get, or 10-20% return or something on the investment, right? What is the expect, can you talk about that? What is the expected returns on something like this? What
Well,
is
it certainly is positive.
Okay, you don't want to share?
No,
Do
well,
you
we wouldn't be able to go into that. But I'd also like to touch on what you were just mentioning. When we looked into this, GE actually hired a third-party consultant to look at the overall carbon footprint impact that we were doing. They wanted to satisfy the question: is what you're going to do with the wind turbine blades with the cement co-processing, is it actually a bigger carbon footprint than if you just did nothing and took it to the landfill or did something else with it? And the feedback from that was, this is a significant improvement on the CO2 footprint, even with factoring in the transportation. Obviously fossil fuels are used for the trucking and so forth. They were incredibly responsible in looking at that and making sure that what they were doing to address the short-term need wasn't having a detriment from a long-term solution standpoint. And that was also very, I think, responsible on their end, and it also helped us make a decision on our end. It's not only a business case, but is this something that we want to be associated with from a reputation standpoint? And that also helped us click that box to say absolutely.
What's that like, going through kind of an auditing of your process by a third party? Like, all right, let me look at all your data. Let me look at, how much you can move.
You've got to be transparent, and there's certainly confidentiality agreements and that sort of thing that are in place. So you're reasonably protected when you've got to show those types of things and share intellectual property and what you're doing. But that was on both sides of the fence, because GE Renewables had to do that as well. So it wasn't just Veolia. Again, it goes to the partnership aspect between GE Renewables and Veolia.
Very exciting to hear that this is happening. Is there any particular number you could talk about publicly in terms of, like, if I have you back next year, what's your goal for this?
Sure. So, right now, and it's out there publicly, our facility can process over 20,000 tons of material a year. That's what we've geared up to do. I'd love to be able to say that we're doing more than that. At some point in the future, I'd like to say that we've expanded and not only have our facility in Louisiana, Missouri, but perhaps there's one on the West Coast and there's one on the East Coast. Having regional applications of this helps manage the transportation costs, as you mentioned. So, we are 001 here in Louisiana, Missouri. I'd love to, in a year or two, say that we've got other facilities throughout the U.S. and, more importantly, throughout the globe. Veolia is a global company. We have business in over, I believe, 60 countries throughout the world. And wind energy and renewable energy isn't just in the United States. As I mentioned, China is huge. Certainly Europe is huge. And so are other countries. I've gotten calls from Portugal, Chile, Peru, Taiwan, you name it. There's been calls from Veolia colleagues all over the globe. I'd love to be able to say that we're doing that. And most importantly, on my own personal list, is I'd like to see more renewable energy repurposing or recycling. So PV solar, the newest generation of electric batteries. What we are very poor at as a society up until recently is we've figured things out to meet the immediate need without a whole lot of vision on what to do at end of life with that. Think nuclear power. I come from the nuclear industry. So, one time the energy was supposed to be so cheap, you could give it away, and that kind of drove nuclear power initially. We've got a number of nuclear power plants throughout the globe. What happens at the end of life with nuclear power? And we still, in the U.S., don't have a concrete solution to that, and that continues to hinder the industry. Uh, Same thing with building hydroelectric dams. You see hydroelectric dams being deconstructed in order to reestablish the waterways. So what we've got to do, and what I believe the wind industry in particular is doing now, is really coming into that whole circular economy, engineering something in the beginning so that it's easier to dismantle, recycle, reuse that material at the end of life. We haven't really done that globally until recently being maybe the last 10 or 15 years. So I think we're going to see more and more of that. I think there's going to be a huge push for that going forward.
Hey Chris, listen, thanks for the time. I kind of want to, you've been in this game for a long time. You've seen a lot, and as I've been in computers for so long, you get jaded after a while for certain things. But where's your muse or your interest now, where you get some inspiration? And let's not use your immediate circle of colleagues, but where are you what's out there that's just kind of been inspiring you, and that you have some lessons that you've brought back, whether it's a book or another company and the innovations that they're doing. What could you pull off the top of your mind?
Sure. So I have been jaded here recently in the last year. So what I'm really juiced about is what I'm calling renewable energy circular economy solutions. Um, PV solar is even more so than wind, and there's no real solution in the United States on what to do with PV panels. Veolia has a process in France where we recycle those. In order to make renewable energy work, you're going to have energy storage, which means a new generation of batteries. So again, what do you do with those at end of life or some sort of catastrophic failure in such a way that it doesn't hurt the environment? I'd say that's my passion here lately is I'm a firm believer in renewable energy. We're going to get there as a globe. We're going to get to renewable energy. Getting there in a responsible manner is going to be really important. And we can't dismiss other innovative opportunities from an energy mix standpoint, whether that's small modular nuclear reactors, whether or not it's some other form of use of fossil fuel. There's a steel plant that we help manage in Europe where they're taking the CO2 gases, they're capturing those CO2 gases, they're using that to grow algae, and then the algae is being converted into bioethanol. That type of stuff is really cool, and it's not one dimensional, it's multi-dimensional. And now you're talking about the steel industry making bioethanol. Who would have ever thumped that? So those kinds of things are really the things that are very, very interesting to me. And if we can leverage that type of circularity, it's going to make the planet a better place. Don't mean that to sound corny, but that's exactly where we've got it.
It's the everyone's adapting to the new reality that we have to respond in some particular more responsible way. But you can't just turn the light switch off on fossil fuels. It's just that's not.
You can't, and
that's just
what people don't realize that the war on oil is actually creating a greater generation of coal-fired power plants in 2021 and going into 2022. You can't just have a regulation or an executive order and expect it to happen in a matter of a couple of years. It takes decades to get to where we will need to be. We just need to get there in a responsible way, in a very cohesive and long-term strategic way.
Chris, thank you so much. Thank you for giving us an insight into this world. I, wish you the best of success with this new one. And I'd love to have you back in a year and, let me know that you have more than a couple of processing plants. So let's see where this goes.
I enjoyed the opportunity, Ernesto. Thanks. I look forward to talking with you in the near future and let you know where we've advanced and how we're doing. That'll be exciting.
All right. Thank you. And thank you guys for listening. I hope this inspires you to think a little bit differently about the world. Take care.
Visit throughthenoise.us for more episodes and subscribe to our newsletter. This show is produced by Through the Noise Consulting, uniting external communications and internal IT functions to ensure data and privacy are protected while creating innovative communications platforms. Want to start your own podcast? We can help. Visit getthroughthenoise.com to learn more.